Okay, today we're going to go ahead and discuss section 1.2, graphs of equations. And as I've mentioned to my students before, this semester will be probably your easier semester in pre-calculus because last semester with trig, it was a whole lot of material that you weren't used to with trig such as sine, cosine, tangent, secant, cosecant, cotangent. This time, this semester, you're going to be relearning everything that you're learning in Algebra 2 right now, or everything that you've learned in Algebra 2 spring semester, just a little bit more in depth. So we're going to go ahead and go on to section 1.2, which is graphs of equations. And we're going to start with the most basic type of graph, uh, which in this case is example 1. It says, sketch the graph of the line y equals negative 3x plus 5. Now, obviously, I've stated that this is a line, but you should have already made the connection that y equals negative 3x plus 5 is a linear function. It is a linear function. It's actually in the form y equals mx plus b. Y equals mx plus b. So let's go ahead and take a look at that function right quick. I'm going to type it here, the equation y equals mx plus b. You have seen this equation or this form before, specifically in your Algebra 1 class, and hopefully you will remember or make the connection that the letter M in Algebra 1 stood for slope. Okay, and then you should also make the connection, or you should remember, that the letter B was your y-intercept. Okay, just a little side note that I usually like to tell my students is that sometimes a lot of people always say, well, why is M a representation of slope? You know, traditionally someone would say, well, wouldn't it be the letter S for slope? And the reason why is because one of the founding fathers of algebra or calculus was Descartes, and he was actually French. And so he made the connection that slope was in regards to climbing. You're either climbing up or you're climbing down. And in French, the word for climbing is, and it may be wrong, I may be spelling it wrong or even saying it incorrectly, but I believe the French word to climb is to monter. And that's why, or that's where the M comes from. Same thing with the y-intercept. You know, a lot of you may ask, well, why is the y-intercept represented with letter B? And remember that the y, it's called the y-intercept because it crosses the y-axis. Well, that intersection in French is bisect. And so that's why the y-intercept is represented by the letter B. So just a little side note there for you. So let's just go back to this slide, and it says y equals negative 3x plus 5. Let's recall and use our knowledge from Algebra 1. What do we know? Well, so far we know that this is a line. The next thing that we know is that it's going to be a slope of negative 3. Thus, it's going to be a falling or a decreasing line. And then we also know that it's crossing the y-axis at not only a 5, but a positive 5. So it's crossing the y-axis at positive 5, and it's a line that's falling. Now let's just say you didn't know all of that information. Well, we would, like you've learned in the beginning, before you actually learn some algebra, I believe you would have learned to basically use a t-chart or a table. You know, pick random values, nice numbers, and then what do you need to do? So I've picked these values for x. What would you need to do so that you can get the y values? That's right. You would need to plug each of these values in for x, do basic arithmetic, and then you would get the y value. So let's go ahead and try negative 2. So I have negative 3 times negative 2. Negative 3 times negative 2 will be a positive 6. You add 5 to that and you get 11. Okay, and then we get negative 1. Negative 3 times negative 1 is a positive 4, plus 5 is 9. I'm sorry, positive 3. Plus 5 is 8. So at negative 1, my value is going to be 8. Then we plug in 0. Well, 0 times anything is 0, plus 5 is 5. So we get 0, comma 5, which is right there. Then we plug in 1. Here we go. Negative 3 times 1 is a negative 3, plus 5 is going to be a positive 2. And so on and so forth. At the end of the day, if you remember from geometry, or at least I hope you remember, you need just 2 points to create a line. So as you can see, I've only plotted 0, comma 5, and then 1, comma 2, and connected those lines, and I get my picture of the line that represents y equals negative 3x plus 5. As you can see, it is a falling or a decreasing line going through the y-axis at positive 5. Okay, x and y intercepts. This is the basic definition of x and y intercepts. To find the x-intercepts, let y be 0 and solve the equation for x. To find the y-intercept, let x be 0 and solve for the equation for y. Remember, like I tell my students, the reason that it is called the x-intercept is because it crosses the x-axis. The reason it is called the y-intercept is because it crosses the y-axis. So take a minute or so to copy those definitions down, and then we'll probably do some examples. Okay, before we start with an example, I want to share with you what I tell my students. And it's this. When you hear the word x-intercept, I'm going to call it x-int for short. Like the slide says, we know one thing for sure that happens at the x-intercept. And again, this is what I tell my students. One thing that we know for sure that happens at the x-intercept is that y is equal to 0. Likewise, we're going to use that same logic, and what do we know is true at the y-intercept? Well, we can say that at the y-intercept, x is equal to 0. That's the definition that you just copied down. But anyways, the x-intercept has synonymous words. Whenever you see the words x-intercepts, you also may run across the word roots, You also may run across the word zeros. You also may run across the word solutions. And all of those right here, all of these, x-intercepts, roots, zeros, and solutions, they all mean the same thing. Y is equal to 0. And you may encounter Mr. Marks or myself interchangeably use those words. I may say x-intercepts, and then a couple sentences later I may say roots, or so on. So I just want you to get in the habit of making the connection that all of these vocabulary terms mean the same thing. So going back to the slide, we're going to go ahead and do an example. It says, find the x and y intercepts of the graph x equals y squared minus 3. Okay, so x equals y squared minus 3. Alright, the first thing that I'm going to do is I'm going to, I don't like that 3. Let me change it. Here we go. Much better. Alright, I'm going to go ahead and do the x-intercept first. And like I've said, what do we know happens at the x-intercept? Okay, true. What happens at the x-intercept is that y equals to 0. What does that mean? That means that now everywhere that I see a y, I can now plug in a 0. So here we go. I'm going to go ahead and start. I always like to start with my equation first, the given equation, x equals y squared minus 3. Now I'm going to plug in the fact that I know that y is equal to 0. So I'm going to say, okay, x equals 0 squared minus 3. Okay, and then I'm going to clean this up. In other words, I'm just going to continue to solve and use basic arithmetic. 0 squared is 0 minus 3, and 0 minus 3 is equal to negative 3. That is the x-intercept. But I also want you to see it in the alternate way that you may see it in the book. If you were taking a multiple choice test like your 9 weeks test, you will probably see it in a different or alternate way. And that's this form right here, coordinate form. What did we get for x? We got negative 3. Great. But also, what do you know is true for the y? Y is 0. Perfect. So this is the alternate form that you're going to see it as. Okay, so either one of these I would accept. I'm not sure about Mr. Marks. He'll probably accept it, but you need to make sure that you make the connection if you're taking the multiple choice that it means the same thing. Alright, so now that we've done the x-intercept, we're going to go ahead and now find the y-intercept. Alright, so one thing that we know for sure about the y-intercept is that x is equal to 0. Okay, that's one thing we know for sure. So, if we start off with our equation, x is equal to y squared minus 3. We're going to go ahead and now plug in what we know is that x is equal to 0. So, every time I see an x, I'm going to plug in a 0. So, I'm left with 0 is equal to y squared minus 3. We're going to move this minus 3 to the other side. When you move something to the other side, the sign changes. So it went from a negative 3 to now